So we're on page 21, topic 6, and we're going to do some problems on graphing linear equations. And we're going to do problems 1A, 1D, right over here. And then from problem 2, we're going to do I, K, M, and O. So I, K, M, and O from problem number 2. So let's get started. And 1A on page 21. In this case, we're given the value of x equal to 1 in an ordered pair. We don't know what the y value, and then we're given the y value but not the x value for a second ordered pair, and we have the equation. So we need to know what is the, if x is 1, what is the y value equal here? And if y is 4, what is the x value? And then, so we've got to complete the ordered pairs, and then we got to graph it. So that's what we're going to do. So let's start with this ordered pair here. We know that x is equal to 1. We're going to substitute x equal to 1 into this equation. So we into the equation y equals 3x minus 2. So y will equal 3 times 1, because we've replaced the x with 1, minus 2. 3 times 1 is 3. Minus 2 is 1. So when x is 1, y is also 1. So now we know here the x is 1, and we found that y is 1. So we know one ordered pair. And we can't draw a line for, we need 2 points. So we're going to now calculate, given that y equals 4 for this equation, what is the value of x that fits that. So we're going to take the original equation and we're going to replace the y with the 4, which is what we're saying up here. We substitute y equals 4 into the equation, and we're going to calculate what x is. So we transpose the minus 2 from the right side to the left, which means it becomes a plus 2. 4 plus 2 is 6. 6 equals 3x, or we could just reverse it and say 3x equals 6, in which case x equals 2. So when y equals 4, we have found that x equals 2. In the first problem, we were given x equal to 1, and using the equation, we found that y equals 1 when x equals 1 when plugged into this equation. Similarly, we were given y equals 4. We substituted over here, and then we solved for x and found that x was 2. So we now have 2 ordered pairs. We have 1, 1, and we have 2, 4, and we can start to draw a graph. So here, roughly speaking, here's the point 1, 1 right here. X is 1, y is 1, and this is the point 2, 4 marked with the letter X. So if we have 2 points and they lie on a straight line, we just need to connect the points and extend them in both directions to find the graph for that. So we fulfilled, first of all, we filled in the ordered pairs, the missing components of the ordered pairs, and now we've drawn the graph. Now, since we have the graph, we could check with another point, some point that we chose. Supposing we set x equal to 0 in 3x minus 2, we set x equal to 0, which is what we're doing. Y equals 3x minus 2 equals 3 times 0 minus 2. So 3 times 0 is 0, minus 2 is minus 2. So when x is 0, y is minus 2. So we have another ordered pair. Now, if we've drawn this line correctly, this ordered pair should lie on the line. By the way, this point 0 minus 2 is also the y-intercept, because it crosses the y-axis. This is the y-axis, and so this point 0, 2, where x is 0, is the y-intercept, and you can see that just very roughly, approximately, the 0, -2 shown with a red dot does fall on the line, and that supports the fact that we've probably drawn the coordinates of these positions are correct. Now we're going to go into 1D. Same kind of problem here. We're given x and we're asked to compute y. We're given y and asked to compute x, and we can only do that if we have an equation. So in this case, we'll start off and we know that x is 1, and we're going to solve for y when we put it into the equation. So x is 1, here's the replacement, plus y minus 3 equals 0. 1 minus 3 is minus 2. So y equals 2. So 1, 2 is an ordered pair that fits on the line. In other words, when x is 1, y equals 2 when I fit it into this equation. So I have one ordered pair. Now, for the second ordered pair, I'm going to use y equal to 3 here. Here's y equal to 3. I want to know what the x is. So we substitute y equals 3 into our original equation. So I've replaced the y here with the 3. Plus 3 minus 3 equals 0. So when y equals 3, x equals 0. So I've got a second ordered pair. There's my second ordered pair. Now if I take the first ordered pair, 1, 2, and the second ordered pair, 0, 3, and I connect the points joining those two, we get the straight line right here. Now what I'm going to do is check for another point to make sure that these points are correct. I just randomly choose a number, usually a low number, and I'm going to choose here because it's very obvious, this line here. I can see right here, this is the X-intercept and y equals 0 there. I know along this line, the X-intercept, y equals 0 right here at this point. And so I want to know what the value of x is. And so I substitute x plus y minus 3 equals 0. And because it's an intercept on the x-axis, I'm setting y to 0. Plug that in here. X is 3. So it's this probably has the coordinates 3, 0. The ordered pair seems to lie on the line. And that's right, it lies on this line, so approximate. Now these are all approximate. You could draw a graph on proper quad paper or graph paper and substantiate what I've said. If you didn't, this is just a very rough approximation of which we've estimated. Now we're on to I. And here we're asked to use intercepts to graph the following equation. So we're given an equation, and what we're going to do is find the x and y intercepts, connect those, and that should give us the graph for the straight line. So here's the equation. Now I have to use the intercept to do the calculation. So I'm going to find the y-intercept. By that means where it crosses the y-axis right here. This is where a line crosses this axis is the y-intercept. And the value of x along this line is equal to 0. So I set x equal to 0. I put it into this equation, get y minus 1 equals minus 3, 0 plus 1. So because I'm replacing the x with a 0, minus 3 times 1 is minus 3. So I get y minus 1 is equal to minus 3. And y is, if I transpose this over to the other side, I get plus 1. Y is equal to minus 2. So when x is 0, y is minus 2. And that gives me one of the two ordered pairs. So it's right here. Here's the first ordered pair. When x is 0, y is minus 2. I go down 1, 2, 0, minus 1, minus 2, very roughly. It's right there. Now, I need another point, so I do that. I can do the x-intercept. To get the x-intercept, I set y equal to 0. Because along this line here, y is equal to 0. Along this line, y is equal to 0. So, when I set y equal to 0 into the original equation, replace the y with the 0, I get minus 1. I use the distributive rule. Minus 3 times x is minus 3x. Minus 3 times plus 1 is minus 3. So, and I'm going to transpose this minus 3 from the right to the left and make it plus 3 right there. So this has been moved from the right to the left, and I make it 3 minus 1 equals minus 3x. This stays the same. So I get 2, 3 minus 1 is 2 equals minus 3x. I can bring this to the other side from the right to the left, and this from the left to the right, and I get 3x equals minus 2. I divide this by 3 to get x. I divide minus 2 by 3, and I get minus 2/3. So the ordered pair that fits this equation is minus 2/3 comma 0. I've set the y to 0, and I found the x was minus 2/3. So minus 2/3 is not yet minus 1. It's a little short of minus 1. So approximately here, I connect these 2 points, I get the straight line for the equation y minus 1 equals minus 3x plus 1. So now I have 2 points, as I said. I've connected them, extended the line. I'm going to check that the result is reasonable. So I'm going to substitute with another point. I'm just going to choose x equal to 2, plug it into this equation and find out what y is, and then plot that point on the graph and make sure it lies on this line here, So if I substitute x, and I could have chosen other numbers, but I chose a low number because I don't want to put 100 in there or 200 in there. Chose a low number. It could be negative, could be positive. I chose x equal 2, nice simple number, plugged it into the equation, replaced the x with a 2, and so minus 3, 2 plus 1 is 3, minus 3 times plus 3 is minus 9, 2 plus 1 is 3, minus 3 times plus 3 is minus 9. Bring the 1 over to this side, the right side, and I get plus 1, and so y equals minus 8. So when x is 2, y is minus 8. 2 minus 8 should fall on the line. So I plotted approximately. Here is x1, here's x2, and if I go down here, you can see this would be approximately minus 8. So the red dot shows that the initial 2 points are probably correct for the growing of this graph. Okay, same kind of a question here. I'm using the intercepts to draw the graph for this equation. So here what I'm going to do is I'm going to set x to 0 here, calculate y, and then I'm going to put y to 0 and calculate x to get the two intercepts. So we set the x to 0, then we get y equals 1/4 Now I'm going to replace the x with a 0 right here. I get minus 4. Get a quarter of minus 4 is minus 1. So when x is 0, y is minus 1. So the point 0, minus 1 lies on the line. Here it is right here approximately. 0, minus 1. Notice that it is a y-intercept and x is equal to 0. This is a y-intercept. If we set y equal to 0, okay, then 0 equals a quarter x minus 4 because I've replaced this y here by 0. I've replaced this y in the original equation by 0. Then I multiply both sides by 4, so I get 4 times 0 on the left here, and then 4 times a quarter on the right, brackets x minus 4. So 4 times 0 is 0. This 4 cancels with this 4 because this 4 is on the numerator. This one's on the denominator. They cancel. I'm left with x minus 4, which means that x equals 4 when y is 0. So we've set y to 0. This gives me my second order pair, which is roughly here, 4 right here at this point. Now I had the first point, 0 minus 1, that's here. That's my y-intercept. This is my x-intercept. I connect these 2 points, extend the line. Now I'm going to use a test point. So we set, let's say we choose x equal to 2. And we plug it back into the original. It's a quarter. X minus 4, we replace the x with a 2. 2 minus 4 is minus 2. Minus 2 over 4 is minus a half. We can reduce it. So the point 2, comma, minus a half appears on the line. So you can see here x is 2 and here's y is minus a half. It's down about a half of the value on the y scale. There's 2 and so there's the point. And this is a mistake here. This appears to lie on the line. So it does look like it's lying on the line, and you can see I just placed it here, and this gives us some idea that our original points are correct because we chose a random value for x and calculated the corresponding value of y, which was this, to make sure that it does lie on the line. We can do this with any other points that we want to. So number 2m, use intercepts to graph the following equation. Very similar to what we've done, except here we have a problem. If I set x to 0, y is 0. And if I set y to 0, x is 0. So I only have one point. If I want to use the intercepts, I can't really do that. I set x to 0, then y will be 0. If I set y to be 0, minus 2x equals 0, and x is 0. So I only have one point. So what I need to do is find another value to draw the graph. Just choose a low number for x. Y is equal to 2 times minus 2 times x, and we get minus 2. By the way, this should be minus 2 times plus 1. Minus 2 times plus 1 here, and that should be minus 2. The answer is corrected. Just a little bit of an error here in the calculation because it's minus 2x. So this number should be minus 2 and this should be plus 1, but we still get the minus 2. So we have a second ordered pair, 1 comma minus 2. Now the graph can be drawn because we've got the original 0, 0 point right here. That's the origin. The point 0, 0 is called the origin. That's the first point. Here's the point x equals 1, y equals minus 2, right about here. We connect these 2 points, we get a straight line, and we're going to check it with the point x equals minus 1. When x equals minus 1, y equals minus 2x, minus 2 times minus 1, which is plus 2. So the ordered pair, minus 1 comma 2, seems to fit on the line, and let's take a look at that. Does it fit on the line? Okay, here's the point right here, which is minus 1 comma 2. Minus 1 comma 2. Yes, that does seem to fit on the line. Okay, now our final problem, y equals 3. Use intercepts to graph the following equation. Now, here is the equation of y equals 3. So if this is 1, 2, 3 on the y scale, y is 3. It's always 3. No matter what the value of x is, y is 3. So we could rewrite this equation as y equals 3 plus 0 times x, because no matter what the value of x is, y is 3. When x is 2, y is 3. When x is 1, y is 3. When x is minus 1, y is 3. I've just shown here, if x is 2, y is 3. X is minus 1, y is 3. So these are the 2 points corresponding to that. I've just drawn them as dots on the red line. But this line is the equation y equal to 3. Now, just as a bit of additional information, supposing you were asked to draw the graph for x equals minus 2. So the equation could be written as x equals minus 2 plus 0 times y. Because no matter what value of y, x always equals minus 2. So here's the origin. Here's the graph equals minus 2. If y is 2, then x is 2. Doesn't matter. If y is 1, x is minus 2. If y is minus 1, x is 2. Because this is the x-axis, and along this line here, x is always equal to minus 2. So, just to show you, you should be able to draw a graph that has y equals a number is parallel to the x-axis, and a graph that says x equals a number is parallel to the y-axis, which is right here. So this may help you understand how to draw graphs where you're just asked to draw y equals, let's say, 6 or y. Now you can understand that if this is y equals 3, y equals 2 would be underneath it right here. Y equals 1 would be underneath it here, and then you see that y equals 0 along the x-axis, which is something we've tried to stress in this topic. Similarly here, this line is x equals minus 2. If I went over here and drew a line here, this might be x equals minus 1. This would be along this line, this would be x equal 0, x equal 1. So this gives you an idea of how to understand that now along the y-axis x equals 0, because you're moving the line closer parallel to this axis, but moving it closer and closer.